Our problem is that UAS, unmanned aircraft systems, have always been around, but they are proliferating at a rate right now which is comparable to the same as smartphones have in the past. It's really easy commercial trend line for people who want to do harm to the U.S. or to other countries to basically leverage those commercial trends and cause harm with them.
We basically threw a bunch of darts on the board. People had these random ideas for not even just mitigation at that point, but detect, track, identify, and then mitigate.
When we realized that we weren't just trying to defeat, one model of UAV that you can buy from Walmart that's going to come in. So we couldn't build a system that was specific to one type of drone. And so we started with this architecture saying we need to connect multiple things. Now where can we be innovative?
Our concept, we wanted to give a multi-layered approach. So instead of concentrating on a specific solution for one threat or scenario, we wanted to be able to cover a couple different scenarios. So we had a multi-layered approach.
We came up with using a radar and a camera system to detect and identify the drones, and then we engage them using a jammer. And so once it's jammed, it might land or hover, and once it goes into that mode, we can hit it with a net gun to safely capture it, retrieve it for forensic use later.
As far as engaging a UAS, we primarily opted with electronic warfare. In particular, we developed a software-defined radio platform where we can selectively disrupt signals to take down enemy UASs without necessarily disrupting our own communications.
We have two different ways of detecting, both their GPS coordinates and with the sounds that they make. And then for taking them down, we use a long-range jammer and a hunter-killer drone that has a mounted shotgun on it, 12-gauge shotgun.
Our overall concept is called the SPIDER, and that stands for Sense, Predict, Intercept, Deny, and Recover. And it's a two-part system. There's a ground component and an airborne platform. And so the ground component is a series of electrical optical cameras and a laser designator on a gimbal, and that picks up the initial detection of an intruder. And once a intruder has been identified and tracked, it passes it over to, we have a Blue Force UAV with a net system that takes off and goes after and captures it.
We're foaming at the mouth for this because we know what it can do, and we're excited to show it off. And we want to get the reactions. Everybody wants to hear the oohs and ahs. We want to hear those reactions from the judges, and we're ready to win this. Let's go where the rubber meets the road. Let's get it done.
Our solution is probably very different than the others in that we've established the building blocks on which the best parts of the other solutions should be able to plug and play.
So what distinguishes Team SmartHawk's solution is it's multi-layered. We have multiple methods of detection, multiple layers of alert, multiple methodologies for takedown or mitigation.
I think we're in a very good position because our solution, it's not only capable, but it's very flexible and it's adaptable.
I think it went good. I think we're a little disappointed, we couldn't take down another UAV with our Hexhound, but once again, we still kind of are just showing a prototype and a concept. So I think it was still, cool to see it flying. And there's a little disappointment there, but I still think I feel a sense of accomplishment, and I think the rest of the team does too.
We actually got the jammer working for the judges, and we were able to do a longer range test that was a little off plan, just to show them how well our jammer works at longer ranges.
We responded to some UAV threats that would have happened in the area. We picked them up on our radar. Our operator was able to pick up the drones and therefore alert the simulated security forces that would generally come out to respond to the situation.
I think we had a successful end result. I mean, we were able to jam pretty much every drone or everything they kind of put out.
Yes, we do have some successes. Flying fully autonomously with the drone just thinking for itself didn't work so well, but switching back over for it to receive stuff from like the pilot, that was fine. We can still get coordinates, we can still pass over, so all that was fine. It was just letting the drone think for itself that became a problem.
We got to knock some stuff out of the air, so to me that was a success, and getting the detect and tracking kind of going was a big success. That was our first time being able to track with the water cannon with a drone flying in the air.